Hello, good afternoon, my dear students. Welcome to the class. Myself, Bhagyashree Joshi from Sankalp Learning Solutions. Yes, wish you Happy New Year to all of you. Yes, so this year is 2025. Okay, so this year we call it as a mathematical year. Okay, so why we call it as a mathematical year? 2025. Okay, so there is a speciality behind 2025. So what is the speciality? See, 2025. Once again, 1 minute. Okay. See, 2025, it is the square of 45. 45 square is 2025 and it is 2025 is the product of two square numbers. So that is 9 square into 5 square. 9 square into 5 square. Product of two square numbers is 2025 and 2025 is the sum of squares of three numbers, that is 40 square plus 20 square plus 5 square. Yes, so square of three numbers, sum of squares of three numbers, and also 2025 is and also 2025 is cube of nine numbers, sum of cube of nine numbers, that is 1 cube plus 2 cube plus 3 cube plus 4 cube plus 5 cube plus 6 cube plus 7 cube plus 8 cube plus 9 cube. So cube of nine numbers, that is sum of cubes of nine numbers. So this is 2025. So there is a speciality behind 2025. It is square of one number, that is 45 square, product of squares of two numbers, that is 9 square into 5 square, and this is the square sum of squares of three numbers and cube of nine numbers. So sum of cube of nine numbers, that is 2025 is a special year. Okay. So 2025 is a special year. Once again, wish you Happy New Year. So this year brings all the happiness in your life and God bless you. Okay. Yes. Shall we start today's class? Yes, my dear children, today's topic is real numbers. So today's topic is real number. Then what do you mean by real numbers? Before going to start the topic, first we should know what do you mean by real numbers. Okay. So real numbers means what? Real numbers. Already we know the types of numbers. Okay, there are so many types of numbers. If we draw one number line, in that number line, we are going to observe all types of numbers. That means positive numbers, negative numbers, rational numbers, irrational numbers, right? So if we if we consider natural numbers, what do you mean by natural numbers? The group of the numbers that is counting numbers, that includes counting numbers. So counting numbers are called as natural numbers. Counting numbers means what? 1, 2, 3, 4, these all are counting numbers. So group of counting numbers, we call it as natural numbers, and natural numbers are starts from 1. So this is denoted by the letter N. Next comes, if we write natural numbers along with 0. So only natural numbers are there in the number line. No, there is 0 is also there. If we add 0 to the natural numbers, then that set of numbers we call it as whole numbers. So that set of numbers we call it as whole numbers and is denoted by W, right? 1, 2, 3 and so on. Okay. Next. Natural numbers is over, whole number is over. Next comes only 0, 1, 2, 3. Only this type of numbers are there in natural in number line. No, there is negative numbers and positive numbers are also there. So such a type of numbers, that means the set of numbers which include positive and negative numbers along with zero, that we call it as integers, right? So integers include negative numbers, positive numbers and zero. That is, the integers can be denoted by the letter Z, -3, -2, -1, 0. So this is +1, +2, +3. So such type of numbers we call it as integers. So, okay. Next comes rational numbers. Rational numbers means what? The numbers which can be defined or which can be represented in the form of p by q, that we call it as a rational number. See, for example, if I write 2 by 3, so it is in the form p by q. It is a rational number. If I write only 2, is it a rational number? Yes, it is a rational number. Why? Because 2 can be written as 2 divided by 1. So now it is in the form of p by q. So it is also a rational number. That means rational number includes, remember, rational numbers includes integers, whole numbers and natural numbers, right? Next comes another part is there. So here you are going to see that is irrational numbers. So irrational numbers are something different numbers. That means √2, √3, pi, √10, √100, √1000. So such type of numbers we call it as irrational numbers, right? So this is R, this is I, this is Q. So rational numbers is quotient, Q, this is I. So if I include all the numbers, that is natural numbers, whole numbers, integers, rational numbers, and irrational numbers, that set we call it as real numbers. See, if we consider, see, this is one bucket is there. In that bucket, natural numbers are also there, whole numbers are there, and integers are there, rational numbers are there and irrational numbers are there. So all the numbers, the set of all the numbers is called real numbers. What we call it as real numbers. So this is all about the real numbers. Next comes, so in this chapter, in the 10th standard, so in the previous years also we have learned about the real numbers. What do you mean by real numbers and expansion of real numbers, that we learned. So in this year, in 10th standard, we are going to learn that is HCF and LCM. HCF, highest common factor and least common multiplier of two numbers. And next is fundamental theorem of arithmetic, right? So this is very, very important. Fundamental theorem of arithmetic. Theorem of arithmetic. Next, that is irrational numbers. We are going to study about the irrational numbers. Okay. So prove that given number is a irrational numbers. That questions can be asked for 2 marks, right? Okay. So HCF and LCM. Next, fundamental theorem. Okay. So before going to start the topic, first we should know what do you mean by prime numbers? So have you heard about the prime numbers? Prime numbers and composite numbers. Composite numbers. Yes, my dear children. What do you mean by prime numbers and composite numbers? So prime numbers are the heroes in this chapter, right? So prime numbers and composite number. What is the difference between prime number and composite number? Are they same? No. They have different property, right? So what do you mean by prime numbers then? 1 minute. 1 minute. Yes. So prime numbers means what? See, if I write 2, 2, 3, 4, 5, 6, 7. Okay, if I write 2, 3, 4, 5, 6, 7. Sorry. What do you mean by prime numbers? See, 2, 3, 4, 5, 6 numbers I considered. Okay. So 2. Tell me the factors of 2. Okay. So tell me the factors of 2. Factors means what? The number 2 ones are 2. Remainder I will get 0. 2 ones are 2. 1 twos are 2. That means 2 has 2 factors. That is 1 and 2. Right? Like 3 is 1 and 3. Next 4. 4 means 2 twos are 4. 1 fours are 4. 4 ones are 4. How many factors it has? 3 factors, right? So 4 is equal to 3 factors it has, right? So that means 4 is equal to 1, 2 and 4. 6. If you consider 6, 6 is equal to 1, 2 threes are 6, 3 twos are 6. Next, 6 ones are 6. That means 4 factors it has. Next, 7. 7 means 7 ones are 1 sevens are, right? So, 7 ones are 1 sevens are. That means 7 has 2 factors. Only 2 factors, right? 4 has 3 factors. 6 has 4 factors. That means the number which has only 2 factors. That means the number which is divisible by itself or 1. That we call it as a prime number. Then what do you mean by composite number? Composite numbers are those numbers which are having more than 2 factors. Okay. If it has 2 factors, then it is a prime number. More than 2 factors, then it is called as composite number. Okay. So this is about the prime number and composite number. Next comes fundamental theorem of arithmetic. This is very important and this statement can be asked for 1 mark in your examination. Okay. Fundamental theorem of arithmetic. Every composite number can be expressed as a product of primes and this factorization is unique apart from the order in which the prime factors occur. See, what does it mean? That means every composite number can be expressed in terms of product of its prime. That means, see, if you consider 8, 8 is a composite number. So if I do prime factorization, 2 fours are 8, 2 twos are 4, 2 ones are 2. That means 8 can be expressed as 2 into 2 into 2. 2 is a prime number, 2 is a prime number, 2 is a prime number. That means 8 is a composite number and this composite number can be expressed as the product of primes. See, 2 is a prime, 2 is a prime. So 2 twos are 4, 4 twos are 8. So product of primes, right? So if you consider 16, 2 8s is 16. Next, 2 4s are 8, 2 2s are 2 ones. That means 16 can be expressed as 2 into 2 into 2 into 2. That means 2 is a prime number and 16 can be expressed as the product of prime numbers. Okay. Every composite number. Okay. If you take any composite number, that composite number can be expressed as the product of primes. Okay. This is the fundamental theorem of arithmetic. Okay. This theorem is very, very important. Remember. Next one. Any two positive integers A and B, HCF of A and B into LCM of A and B is equal to A into B. That means HCF into LCM is equal to HCF into LCM. That means product of HCF into LCM is equal to A into B. Okay. So any two positive integers A and B, HCF of A into B into LCM of A into B is equal to A into B. So remember, this is very important, A into B. This can be asked in your MCQ questions. Okay. Next comes, shall we solve some multiple choice questions? Yes, my dear students. HCF of 26 and 91 is, what they have asked here? HCF of 26 and 91. So we'll do prime factorization. How to do prime factorization? Already you know. Yes. So 26 and 91. 26. 2 ones are 2 threes are 13. 13 is a prime number, right? So 13 can be divisible by itself or 1. That means 13 ones are 13. So 26 can be, 26 can be written as 2 into 13. Next is 91. 91. So 91 means what? See, in the digit place, odd number is there. So it is not going to divisible by 2. So we'll try by 3. 3 is also not possible because 3 threes are 9, but 1 remains. So 3 is also not possible. Next, 5. 5 is also not possible. Next, we'll try by 7. 7 ones are 7, 31. So 21, right? 7 threes are 21. 13 is a prime number. 13 ones are 13. That means 91 is equal to 7 into 30. Next, how you are going to calculate HCF, highest common factor? Between these two numbers, which number is common here? See, 13 is common. Here 2 is there, 7 is there. So 13 and 13 is common. That means 13 is the HCF of two numbers 26 and 91. Therefore, option B is right. If they ask about the LCM, how we are going to find out LCM? LCM is HCF into remaining factors. So HCF is 13 into remaining factors, that is 2 into 7. So if you do the multiplication of all these all these numbers, then you will get LCM of these two numbers. Okay. Next, the addition of a rational number and an irrational number is equal to. See, observe carefully. The addition of a rational number and an irrational number is equal to rational number or irrational number or both or none of the above. Which option is right here? Yes, my dear students, which option is right here? See, for example, addition of rational number. If I take 2, 2 is a rational number because 2 can be expressed as 2 divided by 1. So, it is in the form of P by Q. 2 and here we are doing addition. Addition of rational number and irrational number. See, root 3 is a irrational number. If I take root 3, 2 plus root 3. If you do 2 plus root 3, then the result will be, it is irrational number. Okay, result will be irrational number. Okay, this option is right. If P and Q are integers and is represented in the form of P by Q, then it is a, see, P and Q are integers. Integers means it may be negative, it may be positive or 0. So P by Q means it is whether it is a whole number or rational number or natural numbers or even number. See, the number can be represented in the form of P by Q. That set of numbers we call it as a rational numbers. We already know about the rational numbers. That means option B is right. Yes? Okay. The total number of factors of a prime number. See how many factors you are going to get in prime numbers, whether it is 1, 0, 2, 3. It is very, very, very basic question. It is the total number of factors of a prime number is 2. Okay. The number which is divisible by itself and 1. See if you consider 3, 3 has 2 factors, 1 and 3. Okay. Like 5, 5 has 2 factors, 1 and 5. Right. So 2 factors. The prime factorization of 96. Okay, so we'll do prime factorization of 96. See, in digit place, it is 6, so it is even number. We'll start with 2. 2 4s are 8. 1 remains, 2 8s are 16. 2 2s are 4. 2 4s are 8. 2 1s are 2 2s are 2 6 are 2 3s are 3 1s are. Right? Next, how many times 2 is repeating here? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 into 3. So it can be written as 2 raised to 5 into 3 raised to 1 or 3. 3 raised to 1 is 3 only. So 2 raised to 5 into 3. So is it there in the option? Yes, it is there. For option A is right. 2 raised to 5 into 3. This option is right. Okay. Next, For any two positive integers A and B, HCF of A into B, A and B into LCM of A and B is equal to whether it is 1, A into B divided by 2, A by B or A into B. So which option is right here? Option D is right, A into B, right? Okay. Find the HCF of 96 and 404 by prime factorization method. Hence find their LCM. Okay. So now we are going to find out the HCF of 96 and 404 by prime factorization method. 96. 96 means 2 4s are 8, 1 remains, so 2 8s are 16, 2 2s are 4, 2 4s are 8, 2 1s are 2 2s are 2 6 are 12, 2 3s are 6, 3 1s are 3. Right? Next, 404. So in the in the digit place, so 4 is there. 2 2s are 0, 2. 2 1s are 0, 1. So 101. 101 means it's a prime number, right? So 101 is a prime number. So 101 1s are. 96 can be written as 2. How many times 2 is repeating? 3, 4, 5. So 2 into 2 into 2 into 2 into 2 into 3. Right? So 404. 2 into 2 into 101. So here 2 is repeating. 2 is repeating. So here also 2 is there. Here also 2 is there. 2, 2. That means HCF is 2 into 2. That is 4. Right? LCM. LCM is HCF into remaining factors. That is LCM is equal to HCF is 4 into remaining factors. 2 2s are 4, 4 2s are 8, 8 into 3. So 8 into 3 into 101. So if you do the multiplication of all these numbers, what you will get? See. Yes, 4 into 8 into 3 into 101. So 4 into 24 into 101. Yes, if you multiply all these numbers, then you will get 9696. 9696. Okay, this is the LCM of these two numbers, and this question can be asked for 2 marks. Okay, find HCF and LCM. Both they will ask. So that is HCF is 4 and LCM is 9696. Okay. If you want, you can take down. Next. See, this is very interesting question. What is the HCF of smallest prime number and the smallest composite number? Yes, my dear students, HCF of smallest prime number and smallest composite number. First tell me smallest prime number. Which is smallest prime number? Yes, 2 is the smallest prime number. Okay, remember 2 is the smallest prime number. 1 is neither prime nor composite. Okay, so 2 is a smallest prime number. 2 is a smallest prime number and smallest composite number. If I write 2, 3 and 4, 5, 6, 7. So 2 is a prime number. 3 is a prime number. So 4 is a smallest composite number, right? Smallest composite number is 4. Now, so factors of 2, 1 into 2 or 2 into 1. So 4. Factors of 4, 2 into 2, right? Into 1, you can write. So here, see if you do prime factorization, 2 2s are 4, 2 1s are 2, 2 into 1. Or 2 means 2 1s are 2. So 2 is common here. Therefore, HCF of smallest prime number and smallest composite number is 2. Okay, remember. 2 is HCF of smallest prime and smallest composite number. This question was asked in CBSE 2018, okay, for 1 mark. Yes. Express 429 as a product of its prime. See, 429. 429. Yes. 3 ones are 3. 1 remains 3 fours are 12. 3 threes are 9. 1 4 3. 1 4 3 means in the digit plus 3 is there. So 13. So 14, 143. 143 means if I do with 3, then it will not possible. So 13. Shall we try with 13? 13 ones are 13. 1 remains 13 ones are 13. So 11 is a prime number. 11 ones are 11, right? So 11 is a prime number. 11 ones are 11. So 429 can be expressed as 3 into 13 into 11. 3 is a prime number, 13 is a prime number, and 11 is a prime number. 429 is a composite number. According to the fundamental theorem of arithmetic, composite number, every composite number can be expressed as a product of prime numbers. Therefore, the product of its prime factors are 3 into 13 into 11. Given that HCF of 135, 225 is 45. Find the LCM. So, two numbers. See, this is HCF of A and B. Okay, A is 135 and B is 225. HCF they have given, that is 45, and find the LCM. That means we need to find out the LCM. Okay, so we know one formula, that is HCF of A and B into LCM of AB is equal to A into B. So here HCF they have given, right? HCF is 45 and A value is 135 and B value is 225 they have given. So substitute all these values in the formula. HCF is 45. LCM we don't know. So LCM we need to find out. A value is 135 into B value is 225. If you transfer 45 to this side, LCM is equal to 135 into 225 divided by 40. Now, 5 nines are 45. 5 fours are 20. 5 fives are 25. Right? 3 threes are 3 ones are 3 fives are. Next, 3 ones are 3 fours are 12. 1 remains 3 fives are 15. So 45 into 15. So 15 fives are 75. 15 fours are 675. So 675 is the LCM of these two numbers, 135 and 225. Okay. Yes. Understood? Okay. Find HCF and LCM of 404 and 96. Already we did this example, and verify that HCF into LCM is equal to product of the given number. So this question can be asked like this also. So find out HCF or LCM, and that HCF into LCM is equal to product of the two given number. Okay, so 404, 2 twos are 0, 2s are 2, 2 ones are 0, 2 ones are. That means 404 can be expressed as This is 101 is a prime number, 101 ones are. So 2 into 101, right? 96. 96 can be written as 2 fours are 2 eights are 2 twos are 2 fours are 8, 2 ones are 2 twos are 4, 2 six are 12, right? 2 threes are next 3 ones are. Okay. So 96 can be written as 2 into 2 into 2. 5 times 2 is repeating. So 2 into 2 into 3. Right. So here 2 is common. Here 2 is common. Next, HCF is 2 into 2, that is 4. Okay. LCM. LCM is equal to HCF into remaining factors. So HCF is 4 into remaining factors. 101 into 2 into 2 into 2. That is 2 to the 4, 4 to the 8, 8 into 3. That is 9696. Okay. So what they have asked, verify that HCF into LCM is equal to product of the two given number. So HCF into LCM. HCF into LCM of two numbers is equal to given two numbers, that is A into B. HCF is 4 into 9696 is equal to 404 into 96. Right? 4 into 9696. You will get 3864. Yes, 38784 is equal to, here also 38784 you will get. So here verify that. Verify means whether they are equal or not. So here these two values are equal, therefore it is verified. What we call it is verified. Okay. So HCF into LCM is equal to product of the two numbers A into B. Okay. So this is verified. Next. See, HCF and LCM of two numbers is 9 and 559 respectively. If one of the number is 27, find the other number. That means HCF they have given, that is 9, and LCM 459. If one of the number is 27, that means A they have given, that is 27. HCF is equal to 9 and LCM is equal to 459 and A is equal to 27 they have given, and B we need to find out. So we know the formula, HCF into LCM of two numbers is equal to A into B. So HCF is 9. 9 into 459 is equal to, A value is 27. B value we don't know. So transfer this 27 to this side. B is equal to 9 into 459 divided by 27. 3 threes are 3 nines are, right? Next, 3 ones are 3 threes are. 3 ones are 1 remains, 3 fives are 15 and 3 threes are 9. So 153 you will get. That means B is equal to 153. One number is 27 and other number is 153. So this is B value. B is equal to 153. This question was also asked in the previous year question paper. That is, find the other number. HCF they have given, LCM they have given, and A also they have given. So we need to find out other number, that is B. Okay. Next, calculate the HCF of 3 cube into 5. See, this type of questions also they will ask. So every time they are not going to ask like this only, 9 and 15, 415. So this type of questions also they will ask. That is 3 cube into 5 and 3 square into 5 square. So calculate HCF of 3 cube into 5 and 3 square into 5 square. 3 cube into 5 and 3 square into 5 square. Yes, here 3 cube is there, here 3 square is there. So if you split this 3 into 3 into 3 into 5, this is 3 into 3 into 5 into 5. So here 3 is common, 3 is common, and 5 is also common, right? Next, HCF is 3 into 3 into 5. That is 3 3s are 9, 9 5s are 45. So HCF is 45. Understood? HCF is 45. Next one. HCF of AB is 12. That means HCF they have given, that is 12. A into B value means directly A into B value they have given. See in the formula, HCF into LCM of two numbers is equal to A into B. This is the formula. So in previous questions they gave A value and B value separately, but here they are what they have given here, A into B value directly they have given, that is A into B. So this value they have given, that is A into B is equal to 1800. Okay, find the LCM. LCM we need to find out. So LCM is equal to A into B, transfer this HCF to this side, it will be HCF, means A into B divided by HCF. Okay, so A into B. What is the value of A into B? That is 1800 divided by HCF is 12 here. HCF is 12. Okay. So this is LCM is equal to 1800 divided by 12. 6 2s are 6 3s are. Right. 2 1s are. So 2 5s are 0. That means LCM is 150. Okay. Now, this is also same. HCF of 306, HCF is 18 and LCM they have given. Okay. Find LCM. Okay. So this is not there. A value is 306, B value is 1314 and this is the HCF. Okay. LCM we need to find out. So this question is HCF into LCM is equal to A into B, right? So A into B, HCF is 18 into LCM is equal to A value is 306 into 1314. Now transfer this 18 to this side. LCM is equal to 306 into 1314 divided by 18. Right. Now, 2 9s are, 2 1s are, 2 5s are, 2 3s are. Okay, 3 3s are. So 3 5s are 15, 3 1s are 3. That means 3 1s are 3 1s are 3, 3 7s are 21. So 17 into 1314 you will get. So 17 into 1314 is 22,338. So this is the LCM of these two numbers. Okay. Yes. So such type of questions also they will ask in the examination. Yes. Next theorem is revisiting irrational numbers. If see, this is also very important. A number which cannot be expressed in the form of P by Q is called irrational numbers. So irrational number means what? If we express the number in the form of P by Q, that is rational number. If we cannot express, means it cannot be expressed in the form of P by Q, that we call it as a irrational number. See, for example, root 3, root 2, root 100, pi, these all are irrational number. Okay, where P, Q belongs to Z and Q is not equal to 0. See, Q is not equal to 0. Let P be a prime number. This is a theorem. Okay, let P be a prime number and P divides A square, then P divides A. Okay, where A is a positive integer. See, for example, if I take A is equal to 10, Then what is the value of a square? A square is 100. See, if I take p is equal to 5, 5 is a prime number, right? See, p be a prime number. That means I have taken here 5. P is a prime number. What is our theorem? If p divide a square, that means if a square is 100, 100 divided 5, 5 2s are 0. That means 5 divides a square. P divide a square. Then p divides a 10 divided by 5, 5 2s are 10. Yes or no? If p divide a square, then p divides a. This is the theorem. Okay. So by using this theorem, we can prove the given number is a irrational number. So prove that 3 plus 2 root 5 is a irrational number. So this question can be asked for 2 marks. Remember, definitely one question they will ask for 2 marks. Prove that 3 plus 2 root 5 is a irrational number. Proof. How we are going to prove? See, assume that first we have to assume. We know root 5 is a irrational number, but for to prove we need to assume that this is a rational number. So for rational number, assume that 3 plus 2 root 5 is a rational number. So what is the condition for rational number? Rational numbers are in the form of p by q. That is 3 plus 2 root 5 is equal to p by q, where pq belongs to integer, right? PQ belongs to integer where Q is not equal to 0. So Q is not equal to 0. So this is very important. P by Q. See, if I consider 2, 2 is a rational number. 2 divided by 1 is a rational number. That means 2 is a rational number. If Q becomes 0, what will happen? 2 divided by 0. See, this is in the form of P by Q. P is 2. Q is 1 here. If Q is equal to 0, what will happen? Anything divided by 0 is not defined only. Therefore, the condition is Q is not equal to 0 and P and Q is equal to 1. That means co-primes of P and Q is 1. Now, to 3 plus 2 root 5 is there. Transfer this 3 to this side. P by Q minus 3 you will get. So 2 root 5 is equal to P by Q minus 3. That means, wait, 2 root 5 is equal to P by Q minus 3. Now, transfer this 2 to this side. That means root 5 is equal to P by 2Q minus 3. No, first we'll take LCM. So 2 root 5 is equal to, here LCM is Q into 1 is Q. So Q, P minus 3Q. Okay, now transfer 2 to this side. So root 5 is equal to P minus 3Q divided by 2Q. Right? P minus 3Q divided by 2Q. Here P minus 3Q divided by 2Q is a rational number. But root 5 is an irrational number. So now this is in the form of P by Q. If the number is in the form of P by Q, then we can say that it is a rational number. But here it is root 5 is equal to P by Q. But root 5 is an irrational number. Right? So root 5 is an irrational number. This is not possible. So our assumption is wrong. Therefore 3 plus 2 root 5 is an irrational number. So this question can be asked for 2 marks. Okay. So prove that 2 plus root 5 is an irrational number. Root 5 is an irrational number, or root 3 is an irrational number. 7 plus 5 is an irrational number. So such type of questions they will ask in the examination. Yes, my dear students, today we discussed about HCF, LCM and fundamental theorem of arithmetic, and we solved some multiple choice questions and 2 marks questions. Yes. Okay. So I hope all questions are clear to you. Okay. Yes. So real numbers. Okay. Shall we stop today's session? Yes, my dear students, study well. Okay. God bless you. Thank you. Thank you so much.